Imagine waking up one morning and suddenly the world feels fundamentally different. Words you've used your entire life vanish from your memory mid-sentence, leaving you fumbling for the simplest vocabulary. The sound of everyday conversations becomes unbearable, as if someone's drilling directly into your skull with each spoken word. You smell smoke when there's no fire, or worse, the aroma of your favorite coffee now makes you gag. These aren't scenes from a science fiction movie or symptoms of extreme stress. These are real, documented symptoms experienced by thousands of people suffering from what doctors call brain fog, and what cutting-edge research suggests might be signs of hidden neurological damage lurking beneath the surface of consciousness. Brain fog has become a household term, especially since the global pandemic brought post-viral cognitive symptoms into mainstream awareness. But what most people don't realize is that certain strange, lesser-known symptoms associated with brain fog might be red flags pointing to deeper dysfunction in your nervous system. Dysfunction that goes far beyond simple tiredness or difficulty concentrating. The medical community has long struggled to understand and validate these experiences, leaving patients feeling dismissed or misunderstood. Today, we're diving deep into 10 unusual brain fog symptoms that rigorous scientific research has connected to potential neurological injury or dysfunction. We're not talking about your typical memory lapses or afternoon fatigue. These are the strange, subtle, sometimes disturbing signs that something more serious might be happening in your brain. With groundbreaking research emerging just this year, we finally have biological evidence to explain what patients have been experiencing all along. Let's uncover what your body might be desperately trying to tell you.
All right, let's jump straight into the list, starting with symptom number 1, word-finding trouble and anomia. You're in the middle of a conversation, and suddenly the word you need just vanishes. Not a complex medical term or technical jargon, but simple, everyday words like chair, Tuesday, or coffee. You know exactly what you want to say. The concept is crystal clear in your mind. You can visualize the object or idea perfectly, but the word itself has disappeared into a mental void. This frustrating experience, known as anomia, or word-finding difficulty, has emerged as one of the key cognitive symptoms in long COVID patients and other post-infectious neurological conditions. Research published in peer-reviewed medical journals has documented this symptom extensively in post-acute sequelae of viral infections. What makes this particularly concerning from a neurological standpoint is that it occurs even under mild cognitive load, in situations where your brain shouldn't be stressed at all. Studies have shown that patients recovering from COVID-19 can experience various forms of aphasia-like symptoms, where word-finding difficulties can persist for weeks or even months after the initial infection is resolved. This suggests that the neural pathways responsible for language retrieval, typically located in the left temporal and frontal regions of the brain, may be experiencing ongoing dysfunction or damage. Word retrieval is a remarkably complex process requiring multiple brain regions to work in perfect synchronization within milliseconds, accessing semantic memory, phonological representations, and motor planning for speech simultaneously. When this intricate system breaks down, it indicates potential connectivity problems between language centers or inflammation affecting these critical regions. Research has documented that nearly half of long COVID patients with cognitive symptoms report word-finding difficulties as their most common speech and language issue, significantly impacting both professional and personal life and serving as a tangible marker of underlying neurological dysfunction that may reflect frontal lobe impairment from neuroinflammation.
Next, symptom 2, heightened sensory overload with stimulation. Imagine walking into a moderately busy coffee shop and feeling like your brain is under complete assault. The chatter of conversations, the hiss of the espresso machine, the clinking of cups, the fluorescent lights overhead, all of it becomes unbearable within seconds. Your head feels like it's burning from the inside, and you need to escape immediately just to function normally again. This extreme sensory overload, often described by patients as a brain-burning sensation, represents a dramatic and frightening shift in how the nervous system processes environmental input. In a healthy, functioning brain, sensory information is carefully filtered and regulated by multiple systems working in harmony. The thalamus acts as a crucial relay station, determining which signals deserve conscious attention and which should be suppressed or ignored. Inhibitory circuits in the cortex help maintain balance and prevent overstimulation. When these systems become dysfunctional due to neuroinflammation or damage to regulatory networks, the brain loses its ability to filter sensory input appropriately. Everything comes flooding in at once, overwhelming limited cognitive resources and causing actual physical discomfort. Research into post-viral neurological syndromes has documented this phenomenon extensively in patients with long COVID. A compelling study published in Oxford Open Immunology included first-person accounts from long COVID patients describing how there are times when I'm reduced to tears by the excess of sensory input. Patients report that stimuli which previously caused absolutely no problems, ordinary background sounds, normal indoor lighting, even light touch on the skin, now trigger immediate cognitive shutdown. The brain essentially hits its processing limit and must withdraw completely to recover. This phenomenon suggests significant impairment in critical inhibitory processes involving dysfunction in the complex networks connecting the thalamus and cortex. Research has directly linked neuroinflammation to disruption in prefrontal and limbic structures, where excess inflammatory cytokines measurably affect brain function across multiple systems.
Next, symptom 3. Phantom smells or distorted smell perception. You suddenly smell burning rubber or electrical smoke when nothing is burning anywhere near you. Or perhaps everything you eat, regardless of what it actually is, tastes like rotting garbage or sewage. These profoundly disturbing experiences, known as phantosmia and parosmia respectively, involve either smelling things that aren't actually present or experiencing severe, often disgusting distortions of actual smells. While smell loss or anosmia became widely known and publicized during the pandemic, these more bizarre and distressing olfactory symptoms often accompany cognitive fog and suggest direct involvement of critical neural pathways connecting the nose to the brain. Multiple comprehensive studies have documented the co-occurrence of smell disturbances with cognitive symptoms in long COVID patients. Research published in numerous scientific journals has shown that parosmia and phantosmia are prevalent late-onset symptoms that can persist for many months after the initial infection. One particularly large longitudinal study found that among people with COVID-related smell loss, the prevalence of parosmia increased substantially over time, ultimately affecting approximately 47% of participants, while phantosmia affected about 25%. These qualitative smell disorders often emerged or worsened during the recovery phase, with some individuals developing these symptoms months after their initial infection had seemingly resolved. The olfactory system has a unique and somewhat unusual direct pathway to the brain, notably bypassing the thalamus entirely and connecting straight to regions deeply involved in memory formation and emotional processing. When viruses or inflammatory processes affect the olfactory epithelium or the olfactory bulb, they can potentially impact deeper brain structures through these intimate connections. Research strongly suggests that COVID-19 can damage both olfactory receptor cells and the supporting cells in the nose, with these effects having lasting consequences on how the brain processes smell information. Phantom smells aren't merely annoying or inconvenient, they indicate that something has fundamentally gone wrong with sensory processing at the cortical level. Your brain is actively generating perceptions without any appropriate external stimulation whatsoever, strongly suggesting dysfunction in the olfactory cortex or closely related brain areas. Next, symptom 4 is intermittent confusion or transient zoning out. You're reading and suddenly realize you've stared at the same sentence for minutes without processing it. These brief mental blanking episodes differ from general slowness. They represent momentary lapses where consciousness flickers, as if your brain temporarily disconnects. These micropauses suggest intermittent failures in network connectivity or transient blood flow reductions. Unlike sustained fog, these episodes come unpredictably. You're fully present, then you've lost seconds without awareness of the gap. This might reflect momentary perfusion issues, where brain blood flow temporarily decreases, neural network synchronization problems, or microfailures in attentional networks. Research documents these episodes as part of long COVID brain fog experience. The intermittent quality suggests fluctuating neurological dysfunction or compensatory mechanisms occasionally failing, allowing brief cognitive disconnect windows.
Next, symptom 5, autonomic dysregulation triggering cognitive decline. You stand up and suddenly the room spins. Your heart races, you feel lightheaded, and your thinking clouds. This connection between autonomic symptoms and cognitive function reveals crucial interconnection between regulatory systems and brain performance. Research extensively documents autonomic dysregulation in long COVID, showing clear links between orthostatic intolerance and cognitive deficits. The autonomic nervous system controls unconscious functions. When malfunctioning, it fails to properly regulate brain blood flow during position changes. Your brain becomes intermittently starved of optimal blood flow and cognition suffers. Studies show long COVID patients frequently report dizziness and orthostatic symptoms alongside cognitive deficits. This demonstrates neurological dysfunction isn't always localized to cognitive centers. Brainstem and autonomic systems maintain the stable environment, allowing brain function. When infections or inflammation affect these systems, cognitive symptoms emerge from poor cerebral perfusion. Patients report brain fog dramatically worsens during dizziness or racing heart episodes. This temporal connection provides clues about the underlying problem, suggesting cognitive dysfunction stems from inadequate or unstable brain blood supply, pointing to vascular and autonomic involvement contributing to cognitive system damage.
Next, symptom 6, sensory fuzziness and disconnected perception. Everything looks slightly blurry, though your eyes are fine. Sounds seem muffled. Touch feels dulled. The world has taken a vague, dreamlike quality, where nothing feels crisp or real. This subtle sensory fuzziness represents strange alterations in how the brain integrates sensory information. This isn't hallucination or sensory loss. Your senses work intact. Instead, how your brain processes and integrates signals has changed, suggesting association cortex dysfunction, regions responsible for combining sensory information to create coherent reality perception. Normal perception feels immediate and clear. When integrative networks become compromised, this automatic process breaks down. Information arrives, but the brain struggles to render it into clear perception. This affects consciousness quality itself. Patients struggle describing it because the problem isn't with specific senses, but overall perceptual experience. Research suggests when white matter or association areas are affected, this generalized perceptual blunting occurs. Studies document long COVID patients feeling things seem not quite real, or there's a barrier between themselves and their environment, indicating higher-order sensory integration process disruption.
Next, symptom 7, emotional flattening or affective blunting. You watch a normally tear-inducing movie, but feel nothing. Good news arrives, but there's just muted acknowledgement. Your emotional range has compressed into a narrow, flat line where strong feelings seem impossible. This emotional blunting, alongside cognitive sluggishness, points to frontolimbic circuit dysfunction, networks connecting emotional centers with cognitive regions. Emotions are generated by specific neural circuits involving the amygdala, prefrontal cortex, and neurotransmitter systems. When disrupted through inflammation, damage, or neurotransmitter imbalances, normal emotional range capacity diminishes dramatically. What's concerning is its connection to cognitive dysfunction. When emotional blunting and brain fog occur together, the problem isn't limited to one system, but indicates widespread dysfunction affecting multiple interconnected networks. Research documents affect and emotional processing changes in post-viral syndromes. Studies show long COVID patients experience emotional regulation changes, with inflammatory cytokines influencing dopamine levels, leading to reward motivation inhibition and anhedonia, the inability to feel pleasure. Combined dulled emotions with cognitive symptoms creates a picture of brains shifted into lower functioning states across multiple domains. This isn't traditional depression, but fundamental reduction in brain capacity to generate the full human emotional experience spectrum, marking deeper neurological compromise.
Next, symptom 8, sleep-wake fragmentation causing persistent fog. You sleep 8 hours, but wake barely rested. Throughout the day, thinking remains clouded. Your sleep, though adequate in duration, has been fractured by countless micro-arousals, brief awakenings you don't consciously remember. These disruptions prevent your brain from completing deep, restorative sleep cycles needed for proper function, resulting in persistent cognitive fog. Studies show many neurological disorder patients experience fragmented sleep architecture while believing they sleep through the night. The brain transitions abnormally between sleep stages, experiences frequent micro-awakenings, or fails achieving adequate deep or REM sleep. Each disruption impairs overnight brain maintenance, memory consolidation, and metabolic waste clearance. Sleep fragmentation's connection to daytime cognitive function is well established. When sleep architecture disrupts, specific cognitive functions decline, including attention, working memory, and executive function. Patients often aren't aware their sleep is disturbed, reporting usual sleep hours, yet showing severe sleep deprivation cognitive function. Research shows long COVID patients frequently report sleep disturbances alongside cognitive complaints, with inflammatory processes, autonomic dysregulation, or sleep-wake regulatory center damage fragmenting sleep architecture. Next, symptom 9. Delayed onset of sensory or painful symptoms. Weeks or months after cognitive symptoms began, you develop new problems. Tingling spreads through hands and feet. Burning sensations appear. Pain manifests in strange patterns. These delayed sensory or neuropathic symptoms, alongside ongoing cognitive decline, suggest neurological involvement may be spreading or evolving, affecting new nervous system areas beyond initial damage sites. This temporal pattern is revealing. When cognitive symptoms appear first, followed later by sensory symptoms, it indicates the process affecting your nervous system, whether inflammation, autoimmune activity, or viral effects, may be progressive or fluctuating. Delayed somatosensory symptom emergence flags neural involvement extending beyond cognitive areas into peripheral nerves or sensory processing brain and spinal cord regions. Research documents this progression in patient subsets. Studies show long COVID can affect the nervous system multiply, with patients developing new neurological symptoms months post-infection, including small fiber neuropathy causing burning or tingling. What's particularly concerning is its delayed nature. You might think you're recovering cognitively, only to have new symptoms emerge, suggesting the underlying process hasn't resolved but continues affecting different nervous system parts over time. Next, symptom 10, AMPA receptor dysfunction. In groundbreaking October 2025 research, scientists identified a biological mechanism behind long COVID brain fog. Using advanced PET brain imaging, Yokohama City University researchers discovered widespread AMPA receptor density increases throughout long COVID patient brains. This represents the first direct biological evidence explaining brain fog at the molecular level. AMPA receptors are crucial for memory and learning, responsible for fast neuronal information transmission. The study compared brain scans from 30 long COVID patients with 80 healthy individuals, finding receptor density significantly elevated in brain fog patients. Remarkably, cognitive impairment severity directly correlated with AMPA receptor increase degree, and these changes linked to immune system activity and inflammation markers. This discovery is revolutionary, providing objective, measurable evidence that brain fog is a real neurological condition. Research showed brain imaging could distinguish patients from healthy controls with 100% sensitivity and 91% specificity. Scientists propose drugs suppressing AMPA receptor activity could offer viable treatment approaches. Other research linked this dysfunction to broader neuroinflammatory processes, where inflammatory cytokines affect brain function across multiple systems. The discovery validates long COVID brain fog ties to measurable metabolic and vascular brain changes, with blood-brain barrier disruptions and hyperactive immune responses contributing to symptoms. This breakthrough offers hope for millions suffering worldwide, providing clear diagnostic pathways and potential therapeutic targets, legitimizing patient experiences and opening doors for developing effective treatments based on understanding actual biological mechanisms driving cognitive impairment.
These 10 symptoms represent far more than just uncomfortable experiences or temporary inconveniences. They're potential windows into understanding hidden neurological damage that might otherwise go completely undetected until more serious problems develop and worsen over time. The recent breakthrough in identifying AMPA receptor dysfunction gives us unprecedented insight into the biological basis of brain fog and validates what patients have been experiencing all along, often without medical support or recognition. If you or someone you know is experiencing any of these unusual manifestations of brain fog, it's absolutely crucial to seek medical evaluation, particularly from neurologists or specialists who are familiar with post-infectious neurological syndromes and long COVID. Don't wait for symptoms to worsen before taking action. The emerging research into long COVID and other post-viral conditions has opened entirely new understanding of how infections can cause lasting neurological dysfunction that affects quality of life in profound ways. These symptoms aren't in your head in the psychological sense that some doctors might have suggested. They're in your head in the neurological sense, representing real, measurable changes in how your brain and nervous system function at the cellular and molecular level. Early recognition and appropriate medical care can make a significant difference in outcomes and recovery trajectories. Don't dismiss these symptoms as just stress, normal aging, or simple fatigue. They deserve proper medical investigation and treatment. Remember, the breakthrough research we discussed today shows that brain fog has biological underpinnings that can be measured and potentially treated. This validates patient experiences and opens doors for developing targeted, effective treatments. If this video was helpful in understanding these complex neurological symptoms, kindly type "helpful" in the comments. That truly motivates us to produce more evidence-based content like this. If you found this information valuable and want to help others who might be struggling with similar symptoms, please hit that like button, share this video with anyone who might benefit from this information, and subscribe to our channel for more scientifically backed health content. Thank you for watching. And please take care of your brain. It's the only one you've got.